Welcome to the WebMD Health Discovered podcast. I'm Dr. Neha Pathak, WebMD's Chief Physician Editor for Health and Lifestyle Medicine. Imagine learning that a new kidney or heart, the one treatment guaranteed to save your life, is just out of reach. That's the reality for more than 100,000 Americans who are currently on a transplant wait list. 17 people on the wait list die every single day. And even universal organ donation wouldn't be enough to meet the need. Today, we're going to discuss xenotransplantation, the bold frontier of transplanting life-saving organs from animals to humans. This practice is being studied as we speak using genetically engineered pigs. We'll take a step-by-step approach to the science, the controversies, and the potential impact of xenotransplantation on those waiting for organs, whether they're kidneys, hearts, and potentially others in the future. We'll discuss what it's like to wake up with an organ that originated from another species. Today, in conversation with Dr. Sanjay Gupta, we'll dig into his exploration of xenotransplantation for his CNN special, Dr. Sanjay Gupta Reports, Animal Farm, streaming now on Max. We'll talk through the experience and learn more about the burning questions. Will transplant recipients still need anti-rejection medications? When could my loved one actually be offered a pig kidney? What do ethicists, including people from different faith traditions, have to say about receiving a non-human organ? By the end of this episode, you'll know why some experts believe xenotransplantation could move from science fiction headline to everyday clinic option within the next 5 years, and what it means for anyone hoping to trade waiting list anxiety for a second shot at life. First, let me introduce my guest, Dr. Sanjay Gupta. Dr. Gupta is the multiple Emmy Award-winning chief medical correspondent for CNN and host of the CNN podcast Chasing Life. Dr. Gupta, a practicing neurosurgeon, plays an integral role in CNN's reporting on health and medical news for all of CNN's shows, domestically and internationally, and regularly contributes to CNN Digital. Welcome to the WebMD Health Discovered podcast, Dr. Gupta.
So great to be here. Thanks for having me back.
I am so excited. We really enjoyed talking with you about your previous documentary, The Last Alzheimer's Patient, and very excited to talk to you about your most current documentary. So, can you talk to us a little bit about the topic of this current documentary and what brought you to work on this over 2 years?
I'll tell you what was really interesting. I was very interested in doing something on gene editing technology. I just thought this was one of those huge advancements in science, and yet very few people were talking about it. You heard sort of bits here and there. And I wanted to do something for a visual medium. Showing CRISPR technology is not the most visual thing. And that's when the idea of what was happening in the world of xenotransplantation started to really hit my radar. And they were using CRISPR in a way that I think was fascinating to me, people hadn't heard about before. And I thought, is there a way to sort of combine these two topics and talk about it in a way that would make sense for people? So it actually started a little bit differently than other documentaries that we've worked on. It started with this idea of the hardcore science and then looking at how that science was actually being used.
So before we dig into some of those concepts and the science around CRISPR, I'd love if you could give us a high-level definition around xenotransplantation.
That was the most common question we got. So, it's sort of most broadly speaking, it means transplanting organs from one species to another. Xeno is this cross-species sort of term, but what it means more specifically is really transplanting organs from animals into humans.
I watched your documentary with my daughter, and it was really interesting because I think there's such an interesting intersection of a couple of things. There's hope for these patients that are very sick and are tied to a dialysis machine when we're thinking about end-stage kidney failure. There's also this cutting edge science that's almost in science fiction realm, watching her just sort of be amazed and awed by the science. And then there were also pieces that can be somewhat controversial. So it's a really interesting intersection of all of these things that come up as we sort of push the barriers of what science can do to improve our health. So I'd love to start with where we are in our current state. Why are we pushing these barriers?
Well, the idea of a transplant waiting list, people who are sick and dying, oftentimes waiting for an organ. It is one of the most human stories, Neha, I think, as physicians that we deal with. We know there's an answer. We know that there's a cure for many of these people, kidney transplant. So there's that hope. And yet there's so many people who are waiting, 100,000 or so people who are waiting. 17 people die every day. And these numbers sometimes wash over you. But I think when you do a documentary, you get to meet these people. You spend time with the families of people who lost loved ones waiting. So can you imagine knowing that there was an answer to have helped your loved one, and yet because of where we are in society right now, they never got that opportunity. So that is, I think, what's driving this more than anything else. And then you couple that with some extraordinary figures. And if you look at most medical advancements, ultimately they had a champion. They had some sort of super passionate advocate around this. And that's the same thing with xenotransplantation as well. So I think a combination of need, where we have come with science, gene editing, and then a few very, very passionate individuals. One of the guys, having watched a documentary, is a guy who had 7 cardiac arrests himself, thought he was going to die, ultimately got a heart transplant, but only after he was really, really sick, almost dead, and he became a transplant surgeon. So he turned that into his life's calling, and he's the one who I think is one of the real champions of this whole concept of xenotransplantation, at least modern day xenotransplantation.
It really strikes me as you're talking, some of these numbers are so staggering, it's hard to really understand what we're talking about in terms of the human toll. But we're talking about 37 million adults. If we're just talking about kidney disease, with chronic kidney disease, 800,000 of them with end stage kidney failure. And to your point, 100,000 people waiting on an organ transplant list.
Yeah.
So, why is it so hard to find human organs for transplant?
So this is really interesting question because this surprised me. I often thought that this was an issue of, are there enough donors? Are there enough people who are willing to say, look, upon my death, my brain death, I'm willing to be an organ donor? And it turns out it's far more nuanced than that. Because, again, as was explained to me by Dr. Robert Montgomery, a very small percentage of people die every day in the United States in a way that is suitable for their organs to be transplanted. So they have significant disease. Sometimes they have cancer that has, made their organs unusable. Sometimes they're too old. Many times they're too old. I mean, most of the organ donors, and this is tough to talk about, but the ideal organ donor is young, healthy, and then suddenly dead. That is not how much most people die, thankfully. So even if every single person in the country said, I will be an organ donor, you still would not have enough organs in this country to satisfy the demand. And keep in mind, the demand that you're talking about, again, the 100,000 people on the waiting list, that's a really pared down demand. There's a lot of people who spend their entire rest of their lives on dialysis. They may never qualify for a kidney transplant, but if you suddenly have more organs available, you could suddenly expand the criteria for transplantation as well. So you could not only save lives, but improve lives as well. So it's a really interesting societal problem, but I think that's another reason it's being driven by these new technologies.
That's really interesting. I had not even thought of that. And then add to that, when you do have an organ donor that can donate their organs, there's this concern around matching that has to be taken very seriously. So then that brings us to the science around CRISPR. If we're already having trouble matching human to human organs, how has this science really helped us shift from being able to then match a pig kidney to a human, given all of these considerations amongst humans?
I think there's two sort of paths that we're talking about here. One is, can you take a pig genome, the genetic blueprint for a pig, and make it compatible with the human genome? Okay, so this would essentially create a situation where the pig's genome is no different than human genomes. They would still have the same challenges that you're talking about. You'd still need to have matches. You'd still have issues of rejection, but it would be no greater than if a human were to donate to another human. Ultimately, with even better gene editing, you could get to the point where you start to more personalize organs. So I'm not just trying to make this compatible for all humans, I'm trying to make this compatible for a specific human. We're not really at that point yet. So there's two main companies that are working on this, bio companies. One is doing 69 gene edits in the pig, and these edits are for everything from looking at issues of a particular protein that a pig may make, that if you put that protein into a human, they would immediately reject it. So you're getting rid of those specific parts of the genome right away. And then you're doing other things that, the way pigs clot their blood is a little different than humans. So you're changing some of those. And then you're adding some genes from humans into the pig genome as well, called transgenes. So when you add all that up, there's one company does 69 gene edits. Another one says we just need 10 gene edits to make this compatible with humans. It's really interesting, and you know this, but I think for a lot of people, don't realize how similar the pig genome is to a human genome. It's actually very, very similar, but some of these edits that happen make it much more compatible. Ultimately, I think we'll get to the point where you can start to get even more specific.
Can you talk a little bit about what that experience was like, touring these biosecure pig facilities?
Yeah. So this idea, at what point, conception to birth, it's interesting because we talked about CRISPR, this gene editing technology, but in order for this to work, there were really several Nobel Prize winning discoveries that went into effect. So first of all, you took a pig, cell, and you can take that from anywhere, from pig's ear or anything. You essentially took out the DNA of that cell, and then you replaced it with this gene edited DNA. That is a process known as IVF, and we talk about that in humans all the time, but you're essentially doing IVF on these pigs. And then you clone those cells over and over again. So you first, are doing gene editing, then you're cloning, and then you're basically implanting that through IVF into the sow, the mother pig. So it's those sows then that you see on these pig farms, which are basically these huge biotechnologically sophisticated facilities. They're super clean. I mean, as was explained to me, the water in the air for the pigs is cleaner than what most humans would have on a daily basis, even the humans who work in that facility. So one of the big concerns is you want to keep these pigs as clean as possible. You worry about infections and things like that. So it's a really, really sophisticated facility, which, does raise the issue, I think, ultimately of cost and scalability and all those sorts of things. But it was pretty remarkable. And there's a few of these facilities in the country right now. When you talk to the people who are at the forefront of this, they imagine these sorts of pig farms with organs suitable for human donation popping up all over the country and, frankly, all over the world.
So let's talk about where we are right now in the process of xenotransplantation, from compassionate care uses to pilot studies and now this FDA approved clinical trial. Can you talk to us a little bit about that journey?
This is the trajectory, right, for any kind of major medical development. You have to show some proof of concept. You have to then do pilot studies. These take a long time to get approved. And now, as you point out, there is a trial that's been approved as well. I'll tell you one interesting thing to get there in terms of compassionate use was, for a long time, people have been talking about xenotransplantation. 45 years they've been talking about this, even tried it in the past. And they just couldn't get buy-in from the FDA to say, hey, look, let's try this in living humans. So what these guys, primarily at NYU, but at a few other facilities around the country, sort of started to think about was this idea of trying to do a xenotransplant into a human patient who was brain dead, which was, you can imagine the ethical sort of discussions around this and getting this through institutional review boards and all that, and getting the family to buy in. So these were patients who said, we want to donate our organs upon our death. But for whatever reason, as we talked about, they were not suitable organ donors. But what they were suitable organ recipients. So these first patients that were done in these most recent phase of xenotransplantation were brain dead. So they took a kidney from a pig and they put it into a patient who was brain dead. And they basically followed them for a couple of months, and they could do all sorts of things. They could biopsy the kidney every day if they wanted. They could measure everything in these patients, and they did. And I think that's really what landed us where we are today. Once they started to get some good data back from those initial patients, That got the approval for a pilot study. That led to an FDA-approved clinical trial, and now, those trials are starting.
And we've sort of been skirting around this, but the ethics of some of the pushing these types of boundaries. So the ethics of doing the research in the first place. And then you interviewed a medical ethicist where you also discussed religious concerns potentially. So let's start there and then we'll dig into some of the other sort of ethical considerations. But there are certain faith traditions where pigs in particular, there's a lot of concern around consuming. So can you talk to us a little bit about those considerations?
Yeah, I mean, this particular issue of xenotransplantation touches on just about every ethical issue you can imagine. There's a doctor who's a cardiac surgeon out of the University of Maryland who is Pakistani, and when he was interviewed, he talked about the idea that he's doing this remarkable science here in the United States, but back home, people really giving him the side eye, in terms of like, what do you like pigs? We don't consume pigs. How can you possibly think about pigs being used as organ donors? Same thing in the Jewish faith. So this was I think, a big concern for people. And Art Kaplan, I think, is the ethicist you're talking about, who also works at NYU with these other transplant surgeons. He spent a lot of time going to faith leaders and saying, like, how do you sort of balance saving a life with these traditions with regard to your faith? Same thing with Catholicism. One of our organ recipients, a devout Catholic, he reached out to the Vatican, say, how do you think about the autonomy of animals when it comes to donation? So there was all these discussions that we're having in the background. Leave aside the scientific principles and were we ready for that? Could we gene edit well enough? Could we keep pigs clean enough? These faith-based discussions were some of the most fascinating, as well as discussions with organizations like PETA, People for the Ethical Treatment of Animals. I think the question of what is an animal's autonomy? Are they here just to serve humans, in terms of providing organs in this case, providing food supply and things like that? You get wildly divergent views. But as you might guess, because this is moving forward, I think those discussions have been had, and I think most people felt comfortable enough with it. Not PETA, by the way. And I give PETA a lot of credit because they are very consistent in their staunch opposition to this sort of thing. They will never be in favor of xenotransplantation, ever. But other concerning, concerns were sort of raised, I think.
It's really interesting. Again, I mentioned that I watched it with my daughter. We come from a Hindu faith tradition, and it was really interesting watching her digest this presentation. And one of her first questions was, well, why can't they just create the organ in a lab using some of these cells? I was like, wait for it, it's coming. But that piece, especially if you're thinking about the energy costs, the cost of creating this type of facility, as you say, just, throughout the country, throughout the world, the cost of the waste. I mean, we were just processing a lot of these different pieces and then the right of that animal as well. We had a very in-depth conversation, but yeah, I'm just sort of curious on your take.
It's interesting to talk to younger people about these scientific developments because in some ways we already seem antiquated. I'm in my mid 50s. And I think, this is a huge technological breakthrough, and it is in many ways. But I think what your daughter is alluding to is probably the future. It's probably where we ultimately go. The idea of, I mean, she grew up in a world where 3D printers were kind of the norm. Can you 3D print organs that are highly personalized, that are sitting there waiting for you? Let's say you had cardiac failure. You weren't ready for transplant yet, but you knew that one day you were going to be, or you were close to end-stage renal disease. Not yet, but you're getting there. Could you get an organ printed for yourself that is with your own cells? So it is your organ. I think that they're going to get to that point, and that may completely obviate this technology that we're talking about.
And then let's talk about some of the scientific concerns, which we haven't really dug into yet, is the risk for infectious disease. I mean, that kept popping up in the documentary as well, that's probably one of the biggest things that maybe keeps up a researcher at night. Can you talk a little bit about that?
When you're working on a documentary like this for a couple of years, every time I interviewed somebody, I would ask them, what is your biggest concern here? What does keep you up at night? And it always revolved around the same topic. This idea that there are what are known as porcine pig viruses that are pretty innocuous in pigs. They don't cause illness in pigs. But if you unleash them on a susceptible human population, that could be really, really problematic. pandemic level problematic. And that would be something that would have happened as a result of this technology. So I think what they think about all the time, it's why these facilities exist to basically keep those pigs as clean of those viruses as possible. They're screened constantly. When I was talking about the 69 gene edits, there are viruses that are embedded in the genome of these pigs. They're called endogenous viruses, and you can edit those viruses out. And so, I think that they feel very comfortable with that. And I think that's why the FDA has given the approval for these clinical trials now to be able to look at these billions of pieces of genetic material that make up the genome and say, okay, here are the concerning parts, and we can edit them out using CRISPR technology. So I think that they feel like they've addressed this concern about unleashing new viruses. But these are early days, and as we say in medicine, you don't always know what you don't know. And so, could there be some other virus out there that sort of has gone undetected? Not so far, but I think that they're going to be watching for that very closely.
So, what does success look like right now for a patient that receives one of these xenotransplants? What can they sort of look forward to as being that benefit?
I interviewed a lot of patients for this. I mean, that's one of the great privileges of, doing a documentary is you just spend time with these patients. So I know what their lives are like. And I think it's worth sort of, when you talk about kidney transplants, looking at what their lives were like before the transplant and then after the transplant. People all know the term dialysis, I think. I think what they don't realize is what a toll it takes on someone's life. So, first of all, just the time, several hours a day, several days a week. It is your life. You can't plan anything else. And the day after you get dialysis, you may feel good, but right away you start to feel miserable again. So maybe you have a day or two in a week where you feel reasonable, as was explained to me. You can't really do anything, but you don't feel very, very sick. That's it. And one of the patients that we talked to got the transplant. He told me that he felt like he was breathing normal air again for the first time. He had energy. He was going on walks with his wife and doing things that he hadn't done in years because of the tolls of dialysis. Transplants can be fundamentally not only life-saving, but life-giving in terms of giving your lifestyle back to you. So it's a significant, significant benefit. I mainly focused on kidney transplants, but they're doing hearts as well. And they're going to be focusing even on other organs such as livers ultimately. And we'll see. One of the people who is very, very focused on this, who runs United Therapeutics, she wants to do lungs. Her daughter has a significant lung condition, and that's what prompted her to get into this field in the first place. So I think there's going to be all sorts of benefits for different types of organ recipients, but it's not just life-saving. I think it's life-giving in terms of what they're able to do.
So you mentioned that there's still the risk of rejection. So people still have to take those anti-rejection medications. Are there other risks that you wouldn't necessarily see in a human to human organ transplant?
I think the biggest one is this risk of infection because you do have different pathogens that exist normally in certain species that don't exist normally in humans. So for the pig, they may appear perfectly healthy. They have no problems at all, and yet they could be harboring this virus that could be really problematic in humans. When they did consents, by the way, just to give you some context, if you were going to get a xenotransplant, not only would you need to be consented, but your family would need to be consented as well because they would be at risk of one of these infections if it were to be unleashed. They would be first at risk. Obviously, the entire human population could be at risk. So Tim Andrews, who is now, I think, the longest survivor of a xenotransplant in the world, him and his wife, Karen, they both had to sign the consent form, and they had lengthy discussions about this. And it's scary. I could be exposed to a virus for which we have not even heard of and we have no cure, no treatment. That's scary. So beyond rejection, which is something that we know a lot more about, and many of the standard anti-rejection medications were used in these xenotransplants, I think the infection thing was the biggest sort of novel concern.
And you mentioned that the patient that you spoke to, Mr. Andrews, is the longest survivor after xenotransplantation. So, what is that length of time, and what can we expect that successful transplant to look like in 5 to 10 years?
I think that it will look very much like what successful human-to-human transplants look like. I think that would be the best way of framing it. So Mr. Andrews is at around 130 days now. You may hear that and think, well, that's not very long, and it's not. But these are early days. There will be textbooks written about Tim Andrews one day because he is going to be the model, I think, of how people approach xenotransplantation. He'll be one of the first, just like we used to talk about baby Faye, who got a baboon heart in 1984, or the first heart transplant done in South Africa. These are the early days of xenotransplantation. But ultimately, I think these transplants should last for years, just like human to human transplants do. And also, to put a punctuation mark on this, within 5 years, they believe that this will become mainstream. This will be something that, if you are an organ failure, this will be something that you will be asked about as a possible option for yourself. I think a lot of times we hear about these amazing scientific discoveries, the human genome, IVF, cloning, in this case, xenotransplantation, transplant immunology. You hear about all these things in sort of bits and pieces, but to see something come together that builds on all of this science and makes it meaningful for people, meaningful in the sense that it saves their lives. It's remarkable to me. So, when we think about science and frankly, nowadays, these concerns that I think people have about some of the funding cuts with regard to science, you don't always know what some of these scientific discoveries are going to lead to. I mean, the United States has been a global leader when it comes to these scientific developments and public health developments for really since the end of World War II. So you're talking 80 years we've been a world leader in this. And what we wanted to tell was a story of triumph as a result of all that hard work over the last several decades.
Yeah, and I think you did that beautifully and really successfully. I just want to again thank you so much for your time and for this conversation.
What a privilege. Thanks for having me.
Thank you so much for being with us today. My key takeaways from this discussion are first, the need for organs is staggering. As Dr. Gupta shared, even if every American pledged their organs, we'd still fall short in meeting the needs of those on our transplant waiting lists. Xenotransplantation is a rapidly evolving option that could move thousands of patients off dialysis and off of transplant wait lists. Early compassionate use cases in brain dead donors and the first FDA approved clinical trial show that these kidneys and hearts can potentially work for months, offering real hope that wait lists could shrink within the next 5 years. Success hinges on more than surviving a surgery. From virus free, biosecure herds to perfecting gene edits to curb rejection and safeguarding against a possible porcine pandemic are also important factors that will impact our ability to rely on xenotransplantation. But the discussion goes far beyond science. Ethicists, faith leaders, and patient families are weighing the rights of animals, the risk of new pathogens, and the consent of both recipients and their loved ones. For more information and a deeper dive, view his special, Dr. Sanjay Gupta Reports, Animal Farm, streaming on Max. To find out more information about Dr. Sanjay Gupta, make sure to check out our show notes. Thank you so much for listening. Please take a moment to follow, rate, and review this podcast on your favorite listening platform. If you'd like to send me an email about topics you're interested in or questions for future guests, please send me a note at webmdpodcast@webmd.net. This is Dr. Neha Pathak for the WebMD Health Discovered podcast.